daawadayaal ku soo dhawaada casharkii saddexaad ee maadada chemistry-ga IGCSE ee fasalka saddexaad ee wiilasha oo idinka imanaya dugsiga casriga ee Al-daarayn ee magaalada Hargeysa waana cashar camaliya ama practical oo ardaydu si toos ah ugu jiraan xarunta laabka casriga ee dugsigan kaasi oo qayb ka nidaamka waxbarashada casriga ee dugsigaasi ugu talagalay ardayda kala duwan ee wax ka barata waana kan casharkii ee daawasho wanaagsan.
Today we want to look at practice about titration, and we need to understand one, what is the aim of this practice of titration. We actually do titration to find how much of a certain solution reacts with a known volume of a known concentration of another solution. So during titration reactions, basically we react an acid with a base, and that is what we call a neutralization reaction. So like you see over here, we're saying an acid-base titration is a titration between an acid and an alkali or a base. The reaction taking place in titration is called neutralization. Now the type of reaction which occurs in titration is known as neutralization because we're actually reacting an acid with a base. Is that clear? Just like the way we are going to do today, we are going to react our acid, which is hydrochloric acid, together with a base, which is sodium hydroxide. Now in this titration, our aim will be to find the concentration of a sodium hydroxide used in this reaction. The concentration of the acid is known and its volume. So we shall have to use a certain volume of sodium hydroxide, then we happen to get its concentration as well. Now, during titration, we need a number of equipments or apparatus. One of them, we need this apparatus. How do you call it? Pipette, very good. Then we need the second one, this one here. Conical, very good. Then we need this apparatus. It's known as? Burette, very good. Then we also need the ring and clamp stand to support the burette. Now still, we also need a white tile. This will be our white background. We simply use the white tile such that we can see a clear color change during titration. Now how does this titration take place? The first step, we shall have to pipette 25 cubic centimeter of sodium hydroxide using a pipette. Then we shall put it in a conical flask. After that, we shall fill our burette with hydrochloric acid, like up to the 0 mark. Then you record the initial reading of the burette. Then after that, we shall have to run the acid to the sodium hydroxide in the conical flask until the color of the indicator turns colorless. Our indicator we are going to use today will be phenolphthalein indicator. So towards the end point, we need to add in drop by drop of the acid such that we don't add in excess or more than what is required. So that is what we are going to demonstrate. Our indicator will be phenolphthalein, but even methyl orange can also work. Even methyl orange can also work, but we shall use phenolphthalein today. Now we need to understand the different color changes that take place during this titration. If at all one is using a phenolphthalein indicator, the color in the acid, it will be colorless. Then in the base, it will be purple or pink. Then methyl orange will be red in an acid, then yellow in a base. So we are going to use phenolphthalein indicator for that case today. So we are going to begin with what we are going to work upon. The question is here. You are provided with a solution of BA1, we are calling it BA1, which is 0.1 molar hydrochloric acid. Now the molar means concentration, okay? Then you are given BA2, which is sodium hydroxide solution. So you are required to determine the concentration of BA2. BA2 is sodium hydroxide solution. You will get the concentration in moles per decimeter cubed and also grams per decimeter cubed. So this is the procedure we are going to follow. We are going to pipette 25.0 or 20.0 cubic centimeter, depending on the pipette. Some pipettes have 25, others have 20, others have 15. Is that clear? So depending on the pipettes that you're going to use, mine I'm going to use is 25. Then we're going to put 25 of Ba2. Ba2 is sodium hydroxide. We place it in a conical flask. That is the first step we're going to do. So I get my pipettes. So sodium hydroxide is here. I use my pipette filler. So after pipetting, there is a brown ring on the pipette. That brown ring, that is where the 25 will stop the solution we're using. So this is sodium hydroxide I've pipetted. So I'm going to release with some little pressure until it reaches the brown ring. So just as you see the down meniscus touching the ring, you stop there, then you put in a conical flask. So we have measured 25 of sodium hydroxide using a pipette, and we have placed in a conical flask. So what will be the next step? Add 2 to 3 drops of phenolphthalein indicator. Everyone has, you have phenolphthalein in your tables. So phenolphthalein is here, that is our indicator we're going to use. So I've added 3 drops. Now the purpose of the indicator is to show you the end point of the reaction when neutralization is complete. Is that clear? So after adding 2 to 3 drops of the indicator, then I have my burette over here. I fill it with hydrochloric acid. So I've added in, and I need to adjust it up to 0. So it is at the 0 mark. We are now going to take the initial reading. So this is our table of results we have here. What is the volume of the pipette we are using in this case? 25, very good. So we record our volume of the pipette used, which is 25.0 cubic centimeter. Then what is the initial reading? 0.00. So we need to understand that these readings of the burette must be to 2 decimal places. So after that, I'm going to begin the titration. I'm going to run the acid from the burette to the conical flask. Then towards the end point, I'll begin putting in drop by drop, such that I don't add in more than what we require. Only a single drop is enough to show you the neutralization point. So it's very important for you that when you're doing the titration, when you're running the acid, towards the end point, if you see the solution is starting to turn colorless, then begin adding drop by drop, because only one drop can show you the end point. So we begin. We add in the acid as we swirl the flask. What is the importance of swirling the flask? Very good. To mix the contents completely or properly. So I'm just close to the end point. I begin adding drop by drop. You see it's close to the end point. I think we need one more drop, isn't it? So add in a drop. It still has some pink traces. That will be enough. Now it turns to colors. Now the white background you see over here is to show you a clear color change. We call it a white tile. So that is the end. So we check the final reading. On my burette it's around 11.123. So when you're reading the burette, you read the down meniscus. The burette increases from up. Up there is 0, so you read it going downwards. So I've stopped at 11.3, according to the down meniscus, 11.3. So we have 11.3 here, 3, 0. 11.30. That is the final burette reading. Then how do we get the volume of BA1 used, the acid? Subtract, very good. So what is 11.30, the final minus 0.00? 11.30, very good. So we again repeat the second time. The purpose of repeating the experiment is to obtain concordant results. So before you repeat the experiment, you must pour away the sample you used at first. Then you rinse your conical flask with clean water. So I pour this sample away. Then I rinse with some water. After rinsing, we again repeat as we did in the first step. we prepared 25 of sodium hydroxide to the conical flask. Now don't record these values, you'll have your values when you're doing your experiment. So we put in a conical flask again. So after preparing 25, again we add 2 to 3 drops of the indicator. 1, 2, 3. So we are going to begin the titration again. What is our initial volume we are going to use in this case? 11.30, that's where I'm going to begin from. However, you can even add and then you begin from 0 again if you want. Is that clear? But according to this one, I'll begin from 11.30. That will be my initial reading. Then the final reading, I'm going to get it after the titration. I'm beginning from 11.30. So I titrate again. So we run the acid from the burette as you keep on swallowing the flask. So you take a keen eye such that the solution, you don't add in excess. So I'm just close to the end point. I need to add in now drop by drop. So my reading here is at 22.5. 22.5, that's the final reading. So what will be the volume of the BA1 used? It is 11.20, very good. Now, I'm not going to begin at 22.5 again. I have to refill in because the acid is almost getting done. So I refill back up to 0. Otherwise, if I don't add in, you might run the whole acid out and you don't have any more to complete the neutralization. So I add in more acid to the burette, back to the 0 mark. So we've added in more acid. Now we are going to repeat the third time. The purpose of repeating the experiment is to get concordant results. So we pour this one away, we wash with some water, we repeat again. Are we observing? So that is 25. Put in a conical flask. So after we put 2 to 3 drops of phenolphthalein indicator, so we need to take the reading of our initial reading of the acid. So I begin the titration again. So with this one I've stopped at the final reading is 11.4. The initial was 0.00. So what will be the volume of the acid added? 11.40, very good. Now, we have completed our table of results. We have done the first experiment, the second and the third one. So we have our table of results there. The volume of BA1, that is the acid, we have used. First we used 11.3, then we also used 11.2, then also used 11.40. So we are going to use those values in our calculations. The first one, we are going to identify the titer values of BA1 used for the average. Now these titer values, we are going to pick out, in simple terms, the concordant results. Those results which are within 0.20 of each other. You can pick like 2. When you're doing your exam, sometimes there are 3 there, so it can be 2, they can be 3. So I'll take the first and second one, because when you try to subtract them, 11.30 and 11.20, what do we get? 0.1. Or you can even take the first one and the third one. It will be the same thing. Is that clear? So the titer values for BA1 used, I will take 11.30 and 11.20. That is the first one. Titer values. BA1 used for the average. BA1 is the acid, is that clear? So we have taken 11.30 and 11.20. Is that clear? So that is the first part. The next one, we are looking for the average of BA1 used. When you're getting the average of BA1, we shall have to get the total of the titer values we use, 11.30 plus 11.20, then we divide by what? 2, very good. So when you add the 2, what do you get? And you divide in your calculator. You get 11.25, the final answer. Very good. Cubic centimeters. It must be to 2 decimal places. So this one here, the value we've gotten is the average volume. The average volume of BA1. BA1 is the acid. Of BA1, the acid that we use. So this is the volume of the acid we use, average. Okay? We shall need it in other calculations. We are looking for, we are calculating the number of moles of BA1 used. Now when you are getting the moles from concentration, you need to remember that if you're looking for moles from concentration, we shall have moles is equal to concentration times volume in decimeters cubed. So we are looking for the moles of BA1. BA1 is our what? We are just naming it BA1 is the acid, okay? So when you look at that question I gave you, the concentration is there for hydrochloric acid. Which value is that? 0.1, very good. Times, what's the volume of BA1 we use? 11.25, but should be in decimeters, so it will be 11.25 divided by 1000. So when you press on the calculator, what do you get for that part? 0.0, pardon? 1125. So these are the moles of the acid we used. Then the next part, we are going to get the moles of BA2, that is the sodium hydroxide we used. We are looking for the number of moles of BA2. Number of moles of BA2. BA2 is the sodium hydroxide, okay? Now, when you are getting the moles of sodium hydroxide, we shall not go through this procedure. We have the equation given to us on the paper. The equation for sodium hydroxide and hydrochloric acid is sodium hydroxide plus hydrochloric acid. What do we produce here? Sodium chloride plus water. So we have the moles of the acid, which is BA1. Now we need to get the moles of the base using mole ratio. And since the mole ratio is mole ratio of base to acid is 1 to 1. How many moles of sodium hydroxide shall we have? To be 0.01125, because the ratio is 1 to 1, and the moles of the acid we have are 0.01125. So the moles of sodium hydroxide would be moles of sodium hydroxide is equal to 0.01125 moles. Those are the moles we are using. Now, the next part is to get the concentration of BA2. Remember, BA2 is sodium hydroxide. And how do we get the concentration? From the formula, concentration is equal to moles divided by the volume in what? In decimeters cubed. Because concentration is required in moles per decimeter cubed. Now, how many moles of sodium hydroxide do we have? 0.01125. And how much volume did we use of sodium hydroxide? How do we get the volume of sodium hydroxide we used? Do you remember that we measured 25 of sodium hydroxide? So the volume of sodium hydroxide, that is the volume of the pipette, because we measured 25, okay? So the volume of sodium hydroxide is 25, and we need to change it to decimeters cubed, okay? So what is 25 in decimeters cubed? 0.025. So these are moles, and this is the volume in decimeters cubed. So what do we get there? 0.045. So let me just take 0.05 moles per decimeter cubed. Is that clear? That is the concentration in moles per decimeter cubed. Now we are supposed to get also the concentration in grams per decimeter cubed. If you have the concentration in moles per decimeter cubed, the one in grams per decimeter cubed is like changing moles to mass. How do we change moles to mass? You multiply by the relative formula mass. Is that clear? Of sodium hydroxide. So we have 0.05 times, what is the relative formula mass of sodium hydroxide? 40, this is a 23 plus 16 plus 1 is equal to 40. So we shall have, when you multiply it there in the calculator, what do you get? 2 grams per decimeter cube. So that is concentration in grams per decimeter cube. So that is what we are going to do. And then we fill in the paper, we record everything. So we can begin.
Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to trace. So now the first thing we're going to do is transfer 25 cubic centimeters of sodium hydroxide into a conical flask. We do that by using a pipette. So place the pipette here. So now we're trying to make it reach that round ring, if you can see. Okay, now it has passed it. Let's try again. Okay, see, it's exactly that round ring. So now just transfer it. So now we've added our sodium hydroxide to the conical flask. It's time for the acid. So we get a funnel and place it on top of a baro. Pretty easy. Then add the acid. Now we're trying to make it reach that zero max. It's just a little bit more. That. So now we first record the initial reading. The initial reading is right now 0.00. 0.00. Okay? Now we add 2 drops of phenolphthalein. Just 2 drops. As you can see, 1, 2, and you see it's a pink. The color of phenolphthalein in a base solution is pink, so this is correct. So now what's next? We do the fun part now. We react the hydrochloric acid with the sodium hydroxide, and we do it very slowly. We do that while swirling the flask, as you can see right now. So now, as you can see, is near the end point. So now we add just drop by drop, as you want to be as accurate as humanly possible. Oh, see, those 2 drops just change this pink color to colors. So now we've look at the final reading. The final reading is 10.9. So we record that at 10.9, and the volume used is the final reading minus the initial reading, which is 10.9. Okay? Now we do this 2 or 3 more times to get concordant results, and then when we get those concordant results, we can find the average of acid used. That's it for me.
What is it?